broad classes: qualitative forecasting and quantitative forecasting. Okay. So in case of qualitative forecasting, we discussed 4 different types: jury objective opinion, then Delphi method, then we discussed Salesforce composite and market survey. Then we started quantitative techniques, and in case of quantitative techniques, we discussed about different components of time series: trend, cycle, seasonal, and random variation in 3 months. Okay, so the techniques we mentioned earlier are the naive approach, then moving average, then weighted moving average. So in case of moving average, we also call it simple moving average. Okay, MA or SMA, shortly we can say MA for moving average or SMA for moving average. So you may find simple moving average in questions also. And according to moving average, we take the data of few periods, recent few periods, and take the mean to forecast the future demand. Okay. So we discussed an example where we determine demands by using 3-month moving average. Okay, 3-month moving average. So in case of simple moving average, all previous historical data have equal importance. Okay, the weight is the same. Weights are equal 1, 1, 1. But in case of forecasting, we know the future events normally found closer to the recent past. Okay. The older data has less impact than the latest data. Okay, that's why we used weighted moving average, because we found that the future demand is close to the recent data. Okay. So in case of weighted moving average, we give different weights for different historical data. Say in this example, 10, 12, 13, 3 actual demands, okay, demands of January, February, and March. So if we want to predict the demand of April,
Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.
Alaikum salam. Please mute your microphone. Okay, so in case of predicting the demand for April using 3-month weighted moving average. So in this case, we have to know the weights. Okay, say in this example, the weights are 3 to 1. 3 for the latest one, 1 for the oldest one. Okay, so 2 is the weight for the between the latest and the oldest one. Okay, then the weights are multiplied with the actual demands of previous historical data. Okay, then divide the total by the summation of weights. Okay, so We can say also weight like 3/6, 2/6, 1/6. So if we keep the range of the weight within 1, okay, so we divide each weight by the summation of weights. Okay, so this is not very difficult for you to understand. Then we discussed exponential smoothing. Okay, in case of uh, moving average, normally we need more historical information. Okay, say for example, 100 days moving average or 200 days moving average. This type of forecasting techniques are used for predicting demand of commodities, price of commodities, and futures, uh, options, then stock price, etc. And very popular in predicting the change in direction, like this. Intersection of two moving averages indicates there will be a change in price or demand in the future. Okay, then we discuss the exponential smoothing technique. In case of exponential smoothing technique, we can avoid the necessity of larger data sets. Okay, instead of say for example 100 days moving average, if we do not have the history of 100 days, we can use exponential smoothing. Okay, but in this case we need a smoothing constant known as alpha. And the formula we used, ft is equal to ft minus 1 plus alpha into at minus 1 minus at minus 1. Okay, so here alpha is the smoothing constant. It varies from 0 to 1. Normally, it will be provided in the examples or questions. Okay, so there is no need to memorize the values of alpha. And the value of alpha changes with situation. For different product, the value of alpha may be of different values. And AT is the actual demand, A for actual, and F is for forecasted demand. Right? T minus 1 for previous immediate past actual demand, and ft minus 1 is immediate past forecasted demand. Okay, so once uh, we know the actual demand of a specific period, we can calculate the demand for future period. Okay, so we discussed this example yesterday. Then we discussed the impact of different values of alpha. So if the value of alpha increases, it follows the trend of the actual demand. More precisely, then the values, the forecast for values alpha is lower. Okay, so if there is any trend, we should always increase the value of alpha. And definitely, which one will be better? We normally use the technique for measuring the errors in forecasting. Okay, known as forecasting error. So to determine the forecasting errors, we use three different type of techniques. We mentioned 3 different type of techniques here. So the first one is mean absolute deviation. Okay, mean absolute deviation. That means we take the summation of total deviation, okay, actual minus the forecasted value, and take the absolute value. Okay, take the absolute value. Because sometimes actual is higher than forecast, sometimes actual is lower than forecasted value. Okay, so we should take the absolute value and take the summation, then divide the summation by number of periods. Okay, number of data we have. So MAD means mean absolute deviation. Say in this example, determining the mean absolute deviation. Here is an example. Okay, the first column is the quarters, 1 to 9. Then the actual ton is unloaded. Okay, this is maybe a commodity unloaded for a specific example. Okay. So actual data is used and the forecasted data is used to predict the future demand. Okay, for the second quarter, okay, we use alpha equal to 0.1, okay, to forecast the demand for quarter 2. So demand is calculated as like this. 175 is the forecasted demand of previous immediate first period. Okay. So this is FT minus 1. Then plus alpha. Alpha is 0.1 into AT minus 1. This is actual demand for the period T minus 1, right? Previous periods. So 180 minus FT minus 1, F for forecasted value. So 175. Okay, so in using exponential smoothing technique, we always need actual demand and forecasted demand. Okay, there is no way to use only the actual demand. We have to use both forecasted and actual demand. So in question, you will find forecasted and actual demand for the first period. Okay. For the forecasted demand of remaining periods, you can calculate. Okay. If forecasted demand for the first period is not available, you will not be able to determine any of the remaining values. Okay. But if the first period's forecasted demand is provided, you can then determine the forecasted demand for all other periods. Okay, so you will be given the actual demands, then you will be given only the first forecasted demand, and if you are asked to determine what will be the forecasted demand using exponential smoothing for the period of 8th quarter, okay, so you will have to calculate all the previous forecasted demands. Okay, without calculating all the forecasted demand, you will not be able to determine the forecasted demand of period 8. Okay, so in some cases, you will find actual demands and the forecasted demand only for the first period. Okay, now So if we use alpha equal to 0.1, we will get this forecasted demand 175, 75.50, 74.75, 73.18, like this. Okay. So if we use alpha equal to 0.5, then we'll get this forecasted demand. Okay. 177, 172, 165, 170, and so on. Now, which forecasting technique is better? Okay. Which one, alpha equal to 0.1 or alpha is equal to 0.5? Which one is better among these two? So to determine that, we have to use the mean absolute deviation for both of these cases, okay? For alpha equal to 0.1 and for alpha equal to 0.5. So here we are calculating the mean absolute deviation. Okay, normally we use the whiteboard in the class to solve the problems. It will be convenient for students to understand clearly when we write all these things in the whiteboard. So it's your responsibility to solve this problem yourselves in your home. Okay, so the actual demand from first to the eighth quarter are given. Okay, first to eighth quarters are given here on the second column. Then the forecasted demand from first to eighth columns are given here. Okay, as we calculated in the previous slide. Then absolute deviation for alpha equal to, it should be alpha, the alpha equal to 0.1 is 0.5, say 180 minus 175 is 0.5, 168 minus 175. So the gap is 7.5, but we take the absolute value, so it's 7.5. Then we calculate the absolute deviations for all other quarters. Okay. Similarly, in case of alpha equal to 0.5, okay, we calculate the absolute deviation 5, 9, 3, 30.75, and so on. Okay. Then we take the total deviation. Okay, in case of alpha equal to 0.1 is 82.45, and in case of alpha equal to 0.5 is 9.8 or 98.60. Okay, so total deviation. So we take the mean. That means we divide the total deviation by the number of quarters in this case. So if we divide 82.45 by 8, we will get 10.31. If we divide 98.62 by 8, okay, we will get 12.33. So from this calculation, we clearly conclude that for the value of alpha equal to 0.1, mean absolute deviation is lower, right? So mean absolute deviation for the forecasted value using alpha equal to 0.1 is 10.31. And in case of alpha equal to 0.5, the mean absolute deviation is 12.33, which is higher than 10.31. So in this case, we conclude that exponential smoothing for this situation, exponential smoothing technique for this situation will give you better result. Okay. Then another technique we can use also mean squared error. So we calculate the error, then square the error. So in the first case, mean absolute deviation, we did not take the squared value. We just took the difference. Okay. But in case of mean squared error, we are taking the square of the errors. So both of them will give you the same conclusion. Okay. But these are these are the few techniques normally used for determining which technique is better. So let's see the example. Okay, by using mean squared error. So 180 minus 75. So the error is 5. So it's 5 square, it's 25, right? It's not very difficult. In case of second quarter, 168 minus 175.5. So it's minus 7.5. Okay, so we take the square. So 56.25. Then in case of the third quarter, uh, error square is equal to 48 and so on. So we take the summation of all squared errors, which is 1526. Okay. So sometimes mean squared error will give you more clearer pictures. Okay, because we are taking the squared value is amplify the situation, right? Amplify the difference by multiplying twice. Okay, so mean squared error is 190 in this case, in this example. So you are advised to calculate the mean squared error for alpha equal to 0.5 and make the decision which technique is better. Okay, and you will find the same result. There is another technique normally we use to measure the errors. So this is known as mean absolute percent error. Mean absolute percent error. Okay. So this is also not very difficult, very simple technique. For the same example, for alpha equal to 0.1, okay, 180 minus 175, so is 5. Okay, 180 minus 175 is 5. So 5 is divided by the actual, okay, the actual demand, 5 by 180. Then take the percentage. Okay, in this case, it's 2.78%. So this deviation is 2.78% from the actual demand. Similarly, for other quarters also, the absolute percent errors are determined, and the sum of all the errors are 44.75. Then we divide the sum by the number of periods. Okay, so we are getting 5.59. So in this case also, you are advised to find the MAPE by for alpha equal to 0.5 and see the results. Okay. So up to this point, do you have any question? So here is the summary. Okay. Here is the summary of focus error. And we have already discussed rounded focus with alpha equal to 0.1. And in case of absolute deviation, and this is for the summary we have already discussed this point. So let's go to our summary, this one. Okay. So using three techniques, we compared the forecasted value for alpha equal to 0.1 and alpha equal to 0.5. Okay? And you see, mean absolute deviation for alpha equal to 0.1 is 10, and for alpha equal to 0.5 is 12.33. So according to mean absolute deviation is greater, right? Alpha equal to 0.1 is greater than alpha is equal to 0.5. In case of mean squared error, for alpha equal to 0.1 is 190 and is 195. Okay. And mean absolute percent error, we get 5.59 and 6.76. So all these three techniques are giving you the same conclusion, same result here. Okay. So as I mentioned earlier, there are situations when you will find some trends. Okay, if there is some trend, known, well-known trend, you can adjust the forecast for the trend, whether it's growing or increasing or decreasing, and the trend may be in the upward direction or in the downward direction. So you can adjust the result forecast, okay, using trend. So how this adjustment is done? Let's see, the equation is a bit different here. There is a component, t minus 1. There is a component, t minus 1. So the part of the trend is added to our previous equation. To our previous equation. This equation, except the t minus 1, is same equation of our previous one. This one. Okay, ft minus 1 plus alpha into ft minus 1 minus ft minus 1. So same equation is here, except the trend part and t minus 1. So how to calculate t minus 1? T minus 1. The formula for calculating the trend is this one. Okay, you have to use this equation to determine the trend for a specific period. Okay, let's see the example. Say exponential smoothing constant is 0.2 and smoothing constant for trends. Okay, smoothing constant for trend beta is 0.4. And in this example, there are 10 months, 1 to 10, and there are 10 months. Okay, AT. A means actual. A means actual. So actual demands of 10 months are provided here. We have to calculate the demand for the 9 months, up to 9 months, the information are given. So we have to calculate the demand for 10 months. Okay. So here is the equation we are going to use. We have to know the actual demand and we have to know the forecasted demand for the first period. Okay. We also need the information of trend for the first period. Okay, trend part, TT, first period. So if this information, the information is not available, we will not be able to calculate the forecast including trends. Okay. So the first step you have to calculate the forecast, including trend for the second month. Okay, the information of past month will be provided to you. Okay, then you will be asked to calculate the forecast for the other months. Okay, so the forecast for second month, we use the equation mentioned earlier. The alpha into A1. A1 means actual demand. This one 12. Okay, 1 minus alpha into F1. F1 is forecasted demand, and T1 is the trend part for the first one. Okay. So once we put these values in the equation, we get the value of F2. Okay. Forecasted demand for month 2. Okay, then we have to calculate the value of T2. Okay, T2. We use this equation mentioned earlier. Beta into F2 minus F1 plus 1 minus beta into T1. And we'll get the value of T2 is 1.92. So you will be provided F1, T1. Then from these two figures and the actual demands, you will be able to calculate all the remaining forecasted values. Okay. So here is the situation. Now, in case of time series analysis, the last technique, trend projection. Okay, if we know the trend perfectly, then we can easily calculate our project demand for different times. So fitting a trend line to historical data points to project into the medium to long range. Okay, this technique is used for medium to long range scenario. And linear trend, we are using only the linear trend. There may have other non-linear trends which are beyond the syllabus of this course. So linear trends can be found using the least square technique. So least square technique, as we know, this is a linear trend. Okay, we know the equation of a straight line. It's like this. If we know the value of coefficients A and B, we can easily calculate the value of future demand, where Y is the demand, okay, dependent variable. X is the time period. Okay. So independent variable. From historical information, maybe we will be provided the historical demands, okay, for different periods. And we know the trend is like a straight line, increasing or decreasing or flat, whatever it is. It should be linear, okay? It should not be non-linear. And this is an assumption that you know the scenario is changing like a straight line. The demand is changing like a straight line. And you have to find the straight line equation. You know, you are already in earlier, so you know how to fit a line in different experiments. So we already had this experience of fitting lines or curves using Excel. Okay, so let's talk an example. So to determine the coefficients, okay, A and B, and for the straight line equation, y equal to a plus bx, where a is the uh, intersecting part of the straight line from the y-axis, and b is the slope. Okay. So if we are given some data, historical data, so for example, time period, and say, consider this example. Okay, you are provided the electrical power demand of the city in megawatt like this. From year 1 to year 7 is 74, 79, 80, 90, 105, and so on. Now, you are asked to fit this demand into a straight line. Okay, so to find the coefficient of a straight line, you will use these values. Here on the x-axis, okay, time period 1, 2, 3, 4, 5, 6, 7 here like this, and demand on the y-axis, okay, y values in megawatt in this case. So if you put these figures into a graph paper, okay, you can easily find the points where it is on the graph paper. Now to find the coefficients, okay, and b, we use this equation. Okay, b equal to summation of xy minus n x bar y bar. Okay, x bar is the mean of x values, and y bar is the mean of y values, and then x square minus n into x bar square. Okay, x bar square. And in case of b, it's y bar minus b into x bar. So y bar is the mean of the y values, x bar is the mean of the. So first we have to determine the value of b, then we can calculate the value of a by using this equation. Okay, let's see how can we do this. On the x-axis, we put year 1 to 7. Sometimes you may find, okay, 2001, 2002, 2003, or 2010, 2011, 2012, like this. So you can convert the years or months into 1, 2, 3, 4, 5, like this for your convenience. It will give you less less time consuming. So if you use 2001 or 2002, 2003 like this, you will get the same straight line, but the calculation will be used. So when you are provided for different years or different months, so you can easily convert those years or months into numbers starting from 1 to 7 or 1 to up to the point information given. So x in x direction, yes, and in y direction, this is the demand of power in megawatt. Okay. So for a city, for the first year, demand is 74 megawatt. For the second year, demand is 79 megawatt. For the third year, demand is 80 megawatt, and so on.
First time.
Okay. Then to find the value of coefficient, okay, to calculate the value of coefficient, we see the equation. We need summation of x, y. So we have to multiply year and demand, electricity demand. Okay, multiply these two and take the summation. We also have to find the summation of x square. So we have to square the years, okay, the values on the x-axis, and we also have to calculate the mean, okay, x bar and y bar, mean of years or time, and mean of 3 months, y. So here is the table. So these are the x values, these are the y values. These information will be provided in the question. Then you have to calculate the value of x square. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, like this. Okay. Then take the summation of all the x squares. Okay. Take the summation 140. Similarly, you have to calculate the value of x to y. So multiply 1 into 74 is 74, 2 into 79 is 158, 3 into 80 is 240, like this. Okay. So then take the summation of x equal to this. And we also have to calculate the mean x bar. So take the summation of x is 28, then divide by the number of period, okay, 7. So 28 by 7 is 4. Then we have to calculate the mean of y. Y values, summation of y is 692. Then divide 692 by 7 is 98.6. Okay. Now we will use these values, x square, summation of x square, summation of xy, x bar, and y bar, to calculate the value of coefficients a and b. Okay. First we calculate the value of b. Okay, like this. So we put the values from the previous table, okay, in this equation, and we can calculate the value of b, which is 10.54. Okay. Then in case of a, you use the value of b from this equation. Value of b is 10.54. So we know value of y bar, we know value of x bar, and we put these values into this equation. Then is 56.70. Okay. Now the equation becomes y equal to 56.7 plus 10.54. So 10.54 is the coefficient b, and 56.7 is coefficient a. Okay, constant a. Now using this equation, we can predict the demand for any value of x, any value. Say for example, we want to predict the demand for the year 8. Okay, demand for the year 8. So we put the value of x equal to 8 in this equation, and we get the demand of electricity in megawatts for the year 8. Okay, so if I request you to calculate the demand for the year 10, you can just put the value of x equal to 10 in this equation, and you can easily calculate the demand for the year 10. Okay, so this is the least square method to calculate future demand, which follows a straight line trend. Okay, so these are the different time series techniques, time series analysis for forecasting future demand. Now let's take the attendance. So please respond to the attendance. Today is 15 November. So roll 201,
Yes, sir.
202,
Yes, sir.
203,
Yes, sir.
204,
Yes, sir.
205,
Yes, sir.
206, absent 206, Abdullah Abrar, 207,
Yes, sir.
208,
Present, sir.
209,
Present, please.
210,
Yes, sir.
211,
Yes, sir.
212, Ishaq Anand, 212.
স্যার ওর মাইকে একটু সমস্যা স্যার।
Okay. So is he available in the list?
ইয়েস স্যার, ইয়েস স্যার।
List? Okay. So 13, 213,
প্রেজেন্ট স্যার।
14,
Yes, sir.
15, 17, 17,
Yes, sir.
Sir,
18.
212, sir.
Okay, yes, already given your attendance. So 18. 18. SM Rohan.
Yes, sir. 218.
Okay. 21,
Present, sir.
22,
Present, sir.
23,
Yes, sir.
24,
Yes, sir.
25,
Yes, sir.
26, 27,
Yes, sir.
28,
Present, sir.
29, Yasir Al Samim, 29, absent. Okay, 30, Abrar Mubashir, 30 to 30. 31,
Present, sir.
33,
Yes, sir.
34,
Yes, sir.
36,
Sir, 30.
Maria,
Sir, 36.
37,
Yes, sir.
38,
Present, sir.
39,
Yes, sir.
40,
Present, sir.
41,
Present, sir.
42,
Present, sir.
46,
Yes, sir.
47,
Yes, sir.
48, Muhammad Adil Ibrahim, 49,
Yes, sir.
50,
Yes, sir.
51,
Yes, sir.
52,
Yes, sir.
53,
Yes, sir.
54,
Present, sir.
55, 56, 57,
Yes, sir.
58,
Yes, sir.
59,
Present, sir.
60.
Yes, sir.
72.
Sir, 55 present, sir.
Okay.
Sir, 217 present. Probably শোনা যায় না।
62,
Yes,
Sir, 55 present, sir.
64, 65,
Sir, 64 present.
Sir.
64 present.
Okay.
Network.
So in section B, I am
Present,
repeating the
sir.
absent roles again. 206, are you present?
Sir, present, sir. 206.
Okay. Then 229, Yasir Al Samim, absent. 230, Abrar, absent. Then 248, Muhammad Adil, absent. 256, Nafis Islam, Fardin, absent.
Sir, 255 present, sir.
Yes, I did not mention you
Okay, sir.
absent. Then in section C, okay, starting with 301. Nafisa
Yes,
Sayana.
sir. Present, sir.
Okay, 302,
Yes, sir.
203,
Yes, sir.
4,
Yes, sir.
5,
Yes, sir.
6,
Yes, sir.
7, MD Ashraful, 8, 9,
Present, sir.
209.
308. Present, sir. 309.
309, 308, both are present. Okay. So 311,
308 হচ্ছে
Present, sir.
লোডশেডিং এর সমস্যা হয়েছে তার জন্য মেসেজ দিছে
He is present. Sir.
okay, 11, 12,
প্রেজেন্ট স্যার
13,
Present, sir.
15,
ইয়েস স্যার
16,
ইয়েস স্যার
17,
প্রেজেন্ট স্যার
18,
Sir.
19, 19,
Yes, sir.
20, 20,
Yes, sir.
21,
Yes, sir. Yes, sir.
22,
Yes, sir.
23,
Sir.
24.
307 present, sir. Mic issue ছিল, sir.
Okay. 24 to 24. 324.
Yes, sir. 24.
Okay, 25,
Yes, sir.
26,
Present, sir.
29. Abis Roy. 30,
Yes, sir.
34,
Yes, sir.
35,
প্রেজেন্ট স্যার
37,
ইয়েস স্যার
30, 41,
ইয়েস স্যার
342,
ইয়েস স্যার
44,
Yes, sir. Present.
45, okay, 45, 45 absent, 46, Tanzil, 46, then 47,
ইয়েস স্যার
48,
Present, sir.
49,
Present, sir.
50,
Present, sir.
51,
ইয়েস স্যার
52, 53,
ইয়েস স্যার
54,
Yes, sir.
55,
Yes, sir.
56,
ইয়েস স্যার
57,
ইয়েস স্যার
21 batch, 21 batch 57,
ইয়েস স্যার প্রেজেন্ট
20 batch 57, Mairama, Musa,
Sir, 329 sir. আমার mic off ছিল।
358, absent,
256 present.
okay, 59, 60, 61,
Yes, sir.
62,
Yes, sir.
63,
Yes, sir.
64,
ইয়েস স্যার
66, 68, absent. Okay, the absent rules are 352, then 345, 46, 346, then 357, Maira Momusa. Okay. Then 66 and 68 are absent. Okay. Huh?
স্যার আসসালামু আলাইকুম
Awesome. What is your role?
স্যার 230 স্যার নেটওয়ার্ক ইস্যু ছিল স্যার পরে অন্য ডিভাইস দিয়ে লগ ইন করা লাগছে
230.
Right, sir.
Okay.
স্যার 329 কি দেয়া হয়েছে আমি
The-
আসলে
Yes.
স্যার থ্যাংক ইউ স্যার
264.
Huh?
264.
64 already given. Okay, so
264.
Sir,
yes,
sir, 262 কি প্রেজেন্ট দেওয়া হয়েছে?
260. Yes, yes. Okay.
Sir,
So,
present.
did I mention your student ID as absent?
Assalamu alaikum, sir.
Alaikum salam.
357, 20 batch present, section C.
Okay. Mariam Musa.
Yes, sir. Mariama Musa.
Mariam Musa. Okay. So, let's go to the slide. So, this is the trend line, the green line. Okay, this line, as we know, line fitting curves, and it's a straight line fitting using the points provided. Okay, now let's go to our next point. You will find some seasonal variation in data, as I mentioned earlier. So, how to adjust the seasonal variation? So, in case of seasonal variation, let's look into the example. Okay. Say, from month January to December, okay, for the last 3 years, year 1, year 2, and year 3, we get these figures. Okay. From January to demand, there is some seasonal variation. There is very similar variation. We see that May, June, July, in all 3 years, demand for these 3 months is higher than other months comparatively. So there is a clear trend, and it also evident from this column number 5. Okay, column number 5, average yearly demand. Say average demand for the last 3 years for January is 90. 80 plus 85 plus 105 divided by 3. So we'll get 90. Similarly, we calculate the average demand for all other months from January to December. Okay. Now, the total annual demand is 1128. And from these figures, we have to determine the seasonal index. So, average monthly demand for the whole year, total demand is 1128 divided by 12 months. So, it's 94, the average demand. And we can calculate the seasonal index by using this equation. Okay. Average monthly demand for the past 3 years, okay, past 3 years, divided by average monthly demand, okay, for all the years, okay, for all the years, for all the months, okay. So, in case of January, the average demand for the month of January is 90, but the overall average demand, monthly demand is 94. So the seasonal index is 90 divided by 94 is equal to 0.957. Okay. Then similarly, we calculate the seasonal index for all other months. Okay, for all other months. We calculate the seasonal index. Now we will use the seasonal index to forecast the demand for month year 4. We have actual demand for the last 3 years. Now we will calculate the monthly demand for the year 4 using this seasonal index. So if forecasted demand for the year 4 is 1200, okay, it will be given. Okay, or we can calculate by other models. And the forecasted demand for year 4 is 1200. So we calculate the average forecasted demand for the year, then multiply it by seasonal index. Okay, so for the year 4, forecasted demand for January is 96 using the seasonal index. Okay, seasonal index. So we multiply the average monthly demand with the seasonal index for each month from January to December, and we can easily calculate this monthly demand for the year 4. Okay. So in this way, we can calculate the demand of a seasonally varied product. And you see, by using seasonal index, the demand for year 4 follows same pattern of previous years. Okay. So there is another example. You can check the textbook. You will find detail. And you can find the forecasted data. Okay, this example. Now we are skipping this adjusting trend data. Okay, this slide. So this example you will find from the textbook. Try to solve. It's similar to the previous one. Okay, similar. Now the last topic, associative forecasting. So far we discussed the time series analysis tools. Okay, all the techniques follows. The x-axis is time horizon. Okay, it may be month or year or week, whatever it is. Now there are situations where the demand does not follow the month or time. It depends on another factors. Okay. So in such cases, in this case, we are also using the linear regression method. Okay, as we used in the previous one, linear regression using the same equation, and same formula will be used, same formula. But in this case, the x-axis and y-axis are different. Okay. So in previous examples, on the x-axis we found time horizon. Okay, it may be month or year. Now here the x-axis has different type of values. Okay. So in this example, say for example, McDonald's sales of a shop in millions of dollars. Okay, is 2 million, 3 million, 2.5 million, or 2 to 3.5. And these sales varies with the salary of the people living in this area. Okay, area payroll. So in the corresponding areas, so for example, where the people getting salary of 1 billion, the company sales is 2 million. In the area where people total salary is 3 billion, the company sales is 3 billion. Where the payroll is 4 billion, company sale is 2.5 billion. Okay, so this is the question, and you are requested to determine a forecasted value for other values of payroll. Okay, here we have 1, 3, 4, 2, 1, 7 like this. So using linear regression method, because this is a linear regression, we need the equation for the straight line, which will fit in this data. And for this purpose, as we discussed earlier, we calculate the mean value x bar, we calculate mean value y bar, then we calculate the value of b using the same equation we used in previous example, coefficient, and we calculate the value of a. Okay, using the previous equation. Now we know the equation of the straight line. Okay, now the sales of the company will be like this. There is a constant value 1.75 plus 0.25 into payroll. So if payroll for any area is 3 billion, then we put value of payroll 3 here, then we can calculate or forecast the sales of the company. Okay, this is the straight line. And from this straight line, for any values of payroll, say for example, for 5, the sales will be around 3 billion. Okay. For 6, the sales will be 1.75 plus 0.25 into 6, so it will be 3.25 million. Okay. So this is an example of associative forecasting. Okay, we are skipping a standard error for estimate here for this case. Okay, we are skipping this slide. We are skipping this slide. We are skipping this slide. Okay, so just few important points to mention here. Sometimes we have to identify the correlation between the factors, how strongly or weakly the dependent and the independent variables are correlated. Okay, there are different scenarios. We are just mentioning different scenarios. So in this case, the x and y, right? The correlation of y is negative with x. So negative correlation, positive correlation, the perfect positive correlation, perfect negative correlation. There is no correlation between x and y. So this situation can be explained by correlation factors. Okay, so we can determine the correlation coefficient by using the equation. Okay, this one, and calculate the value. And if the value varies from 0 to 1, so 1 is highly correlated. Okay, 0 means not correlated, like this. I am skipping this slide also. Okay, this slide multiple regression we are not discussing in this course. We are also skipping this slide. We are also skipping the tracking of this. Okay.
So is it not
Okay,
important?
so this is the end of this lecture. Sorry.
So this slide you are skipping, is it not important?
Yes, this is not important for you for this moment. Okay. So we are skipping the multiple regression analysis and the remaining slides. Okay. Now I will conclude this lecture, and for your convenience, normally in the classes, I used to ask the students to solve problems in the class so that everything is clear to the students. But as it is an online class, it's very difficult for you to give or request you to solve problems. So I will be available tomorrow 8:30 online. So you check the slides and try to solve the problems. And if you face any problem, I will try to discuss or explain your problem. Okay, tomorrow 8:30, I will be available. There will be no attendance for tomorrow's class. Okay, so if you have any question or query, you can discuss with me. Okay, is it clear?
Yes, sir.
Okay, so there will be a class test next Thursday, 15 minutes class test on this topic, and check the textbook and the problems. I hope it's not very difficult for you as a IoT students. If you just only go through the examples and exercise, there will be no problem. Okay, so if you have any issue, please let me know tomorrow at 8:30 p.m. and I will discuss your issues.
Sir,
Okay,
we
that's
didn't
the end
get
of
the
this
PDF.
class.
Syllabus.
This PDF is already provided, but yes, okay, I am sending the PDF to the class.
Sir, I missed the attendance, sir.
Yeah, okay. Who are you?
Sir, 229.
229.
Yes.
Okay. So I will send the file, PDF file to you. The slides is already provided in the
কুইজ কবে বললেন?
class next Thursday. So in case of Monday, so both of the sections are requested to attend the class. Okay, as done earlier. And on Thursday, I will take the quiz. So on Monday, the class will be for both of the sections. Okay, so please attend the class.
স্যার আরেকটা জিনিস, কুইজের সিলেবাসটা কি স্যার লাস্ট যে এই দুটো অনলাইন ক্লাস হলো এই দুটো?
The syllabus is only for this topic, forecasting.
ওকে স্যার, ওকে।
Sir, quiz কি এই week Thursday নাকি next week এর?
A week Thursday.
Sir, next week কেন যে এই week
I have
Thursday
to
আমাদের
take
ওপেন এন্ডেড ল্যাব আছে, আর কুইজ আছে তার আগের দিন একটা, একটু টাইট শিডিউল।
a schedule. So
জি স্যার,
How
আমাদের
many-
স্যার পিকনিকও আছে এই উইকে, সো একটু মানে প্রেসার হয়ে যাবে।
yeah, I have to take 2 more cities. Okay,
ইয়েস স্যার।
so let me know the schedule.
স্যার টাইম
Okay, I
পাওয়া যাবে,
will-
4th উইক তো হয়ে যাবে আরেকটা হয়তো 6th বা 7th উইকে নিন।
Okay, normally students are very busy on the last 2 weeks with
জি
labs and other exams.
জি স্যার।
So it's better to take the quiz earlier, but okay, it's okay. So you discuss and let me know the schedule of 2 classes, 2 cities.
আচ্ছা স্যার আমি মানডে আপনাকে কনফার্ম করবো তাহলে।
So on Monday, both of the sections will be available, right?
স্যার কুইজে কি ট্রু ফলস আসবে নাকি এমসিকিউ?
No, there will be no true false. There will be some problems to solve. Okay, in this course, in this city, and you will have to solve problems. So you have to use the equations to calculate forecast some demand in future. Okay, that's it. Okay, assalamu alaikum. So those who have any other questions.